Welcome to High Tech in Heartland. I am with Scott Richardson, and we are talking about all things tech in and around Quincy. Welcome.
Thank you, Bob. And first of all, since I'm an attorney, I'm going to give my disclaimer.
Please do.
Three things. People listening here, just because you hear my remarks today, you're not a client of mine unless I meet you and we agree to form an attorney-client relationship. And then also, since you're not a client and I don't know your specific situation, I'm not giving legal advice, even if I'm a patent attorney, so I might talk about patent things or legal things or what have you. And then finally, I work for an East Coast law firm right now, Robinson Cole, and I'm not speaking on behalf of Robinson Cole. The things I say here today, I'm not representing what Robinson Cole says. I'm just a private citizen who's interested in things high tech, especially things high tech in the Heartland, Bob.
Yes, speaking of which, before we start, you also wanted to talk a little bit about your lovely wife.
You know, I do, because I think I left people with a wrong impression of her. I said she was a reporter for Phoenix TV, and after we got done filming, you said, so did you live in Phoenix, or did she live in Phoenix? It's like, she's from China originally, and Phoenix TV it was formed by a consortium of very wealthy Chinese investors, and they own satellites, communication satellites, and they broadcast into all of Asia, and in particular, they broadcast into China. And so it has nothing to do with the town of Phoenix. It's a Hong Kong satellite TV agency it's like the CNN of Asia.
And Phoenix is the name of the company based out of Asia, so they were not hanging out
there's our
in the desert for that. There's our little clarification. Let's call it a clarification.
Okay, clarification.
So, what is our topic today?
Well, Bob, the topic is actually, and it's not so much a technology as a field of study, and it's the field of epigenetics.
What in the heck is that?
You know, it's funny you react that way. That's exactly how I reacted when I first heard about this like a year and a half ago. I read a book by Sam Keen, and I've had a couple of favorite authors for like over 20 years now. And I've added Sam Keen to the lineup. I love his books, and I read a couple of books about him, and one of the books I read was called The Violinist's Thumb. And it was about DNA. And the way Sam Keen writes is he writes explanations of science topics, and he kind of dumbs them down for the layman, because I know nothing about biology. I'm an electrical engineer by training, and I've had a lot of experience in patent law and a law degree and such, but no biology whatsoever. But I read this book, and in the book he gave and also his books are sprinkled with anecdotes throughout, just interesting anecdotes about the topic. And one of the anecdotes in that book was about the Covalix study. And that was it's the Overkalix study. The Overkalix study. Overkalix is a small town in Sweden, and it's just south of the Arctic Circle. It's like 10 kilometers from the Arctic Circle. Very cold place to live. And it's north of the Gulf of Bothra, which separates Sweden from Finland. And this Gulf of Bothra freezes over periodically, like every winter, because it's so cold there.
Sure.
And 120 years ago, which is when they took the data from, it would isolate the people in Overkalix, and they would be on their own. They wouldn't have anything shipped in or out for several months during the winter. Why would you want to live in a place like that?
Couldn't walk across the ice?
Oh my gosh. I don't know. Apparently not. Maybe it was too cold, or I don't know what the reasoning is. But anyway, because of this, depending on what happened the previous summer, from time to time, they would suffer famines, and they would be in like almost starvation conditions. And so in this study, in the Overkalix study, which was released, I think, in 2002, they looked at the effect of starvation on the parents to the generation of children that was born, and even the next generation, the grandchildren. And they found that there was a strong link to cardiovascular disease and diabetes. And namely, and also it didn't depend on it affected the incidence of diabetes and cardiovascular disease went down dramatically if the parents were subjected to starvation conditions. And interestingly,
I guess that would make sense.
Interestingly, and I read this, I thought, oh yeah, if the mother's starving, whatever, blah blah blah. But it wasn't so much depending; it was actually more dependent on what the father went through. I found that odd, and it wasn't, and also it didn't depend so much on if the father was starving when they conceived the child, but it depended on if the father was enduring starvation conditions during his slow growth period, which is the period leading up to when they go through puberty.
Huh?
Isn't that odd? And
it is.
When I say it had an effect on diabetes, it was like a fourfold difference. Like the people who were eating, bountiful amounts of food during the slow growth period, the men especially, their children had an incidence of diabetes which was 400% higher than the starvation people. Isn't that wild?
Yeah, but I mean, if you're starving, I would think it'd be tough. You wouldn't be getting diabetes, right?
Well, I guess, but anyway, because they were starving during this period, the children that they subsequently produced had a different system. They were built differently than the other children.
I mean, it's not like they're snacking on a bunch of Ho-Hos and Twinkies up there and pizza.
Not in
that should be that should be jacking up their cholesterol or their diabetes or their blood sugar or anything. So it's like, well, what is making that rise? I guess, and it's got to be the genetics.
Actually, it's epigenetics.
Epigenetics.
And I'm gonna throw out a couple of definitions. The first definition I'm throwing out more or less for humor because I read this and it's like, what? But this is epigenetics. Stably heritable phenotypes resulting from changes in a chromosome without alterations in the DNA sequence. Okay.
In English?
Okay, yeah, I cannot make heads or tails of that. It helps if you know that a phenotype is the observable characteristics that are due to a person's environment, that are caused by a person's environment. That helps a little bit. Anyway, so you can just ignore that definition. I just put that in there for some sad humor, I guess. But a little better, and then I'll give an example that actually clarifies it. A little better definition, it's a study of heritable changes in gene expression that occur without alterations to the underlying DNA sequence. Okay. And the thing is, you and I each have about 30 to 40 trillion cells in our body. Mm-hmm. And every cell has a strand of DNA, right? And I was, not having a background in biology or knowing much about the topic, I was always under the standing that, that strand of DNA in each cell in our body, that helped to build us from the time, the sperm cell and the egg cell combined to form a zygote inside the mother's womb, and then, that one cell became two, and then it became four and whatever, and split off. Mm-hmm. I always thought that was the case. Right. But it's not. It turns out that on top of each double helix strand of DNA, there are chemicals and different formations, and those chemicals and formations actually affect gene expression, which genes are turned on and which genes are turned off in the gene sequence. And that's epigenetics. And the example I was going to give is that, I'd always likened a DNA double helix strand to a cookbook, which is not a bad way of looking at it. It's right. Because the thing is, it's more than just a list of ingredients. It's not like the ingredients on the back of a soup can, for example. It's actually the ingredients and the instructions and the orders how to make this, how to make a human being. Which is, that's true, but there's actually more to it than that. A human being's made not just with the human genome, but with also the human epigenome, which is the epigenetics is a study of that. Okay. And the epigenetics, the example I was going to give, it's like if your mother gave you the cookbook she's been using for 35 years, and you got this cookbook, and there are pages that are dog-eared, and there's parts that are underlined and highlighted, and there's little notes in the margins, and then there might even be a few recipes written in here and there. All those extra addendums in that cookbook, that's the epigenetics.
Now you made it relatable.
Yeah.
I got it now.
Yeah,
I got it.
Isn't that a good way of looking at it?
That is. That's excellent.
That is just wild.
Because it's like, okay, mom's banana bread. Well, maybe if we added a little bit of this, it makes it a little bit better and stuff like that. Or if you take something out, it changes it. So yeah, that was these little alterations down the road will, have more of an impact. Yeah, and it's a huge, just burgeoning field of study right now. It's really a hot topic, even though I think a lot of people have not even heard of it. I suspect. Nope. I think most people have not even heard of it. You texted me that, and I'm like, what in the heck is that? Other topics, you texted me like, oh, I've heard of that. Oh, I can look at this. Oh, sure. And I just I looked at it, and I was like, I took one look at I did a quick wiki search. I'm like, okay, I'm just gonna let her talk to me about this because I gotta absorb this a different way. So. Well, you might ask, well, what's the tie-in to the Midwest, Scott? Yes. So there are just a handful of universities in the United States and actually throughout the world, just not too many universities that are the centers that are studying this, and one of them is the Simpson Query Institute for Epigenetics up in Northwestern.
They're one of the top universities that are studying this, right? They have a center, and they have scholars that are researching.
I was going to guess either Northwestern, University of Chicago, or WashU.
Yeah, I probably would have guessed the University of Chicago, maybe Northwestern.
Those are kind of the Midwest Ivy League, isn't it? Those three, you think?
And I suspect that the University of Chicago probably, and even the University of Illinois, they probably have people studying this too. But a Google search tells me that the Simpson Query Institute for Epigenetics is one of the top ones in the world. So.
Well, I wonder how somebody would just get into that. I mean, you saw this topic and you decided to do some thumbnail research and look through it, but how would somebody just sitting there say, epigenetics, I'm going to study that? People like that fascinate me because I have a really good friend of mine whose son is just this math whiz. And so he is studying math at, I think, getting a PhD up at Madison or something like that at Wisconsin. And it's just like, why? I mean, okay, I get it. I need math, but what do you study and how do you enhance that sort of thing? What more is there to learn about math? And it's like, what more is there to learn about things like this? But I'm sure because I have more of a writer's artsy performing vibe DNA. That's my DNA. But this kind of critical thinking DNA, this kind of critical thinking path, I guess that's something probably people think about, and that's why we have people who are geniuses and who do this sort of thing, and then you just got guys like me that are just schleps and run websites for a living. I guess that's how I figure it out.
I think that people go into a field of study like this, or mathematics, or even patent law, because of some stimulus that happened in their formative years, their growing up years. Maybe they had an uncle that was a patent attorney or a mathematician, or quite likely they had a teacher who was just there are some teachers that are they're star teachers, and students gravitate towards them. And you look at all their students, like maybe some math teacher, maybe 20 of his students went on into either become mathematicians or into math intensive fields of study. So,
well, in my case, I loved baseball and listened to the Cardinal radio broadcast and listened to Jack Buck, and I wanted to be Jack Buck. So that's why I ended up doing something along these lines. And, at night, and of course it was on KMOX. Local stations carried it too, but KMOX in St. Louis was the 50,000 watt blowtorch, which went all over the Midwest. So at night, especially if they were playing like a late night game out west, you could listen to it clear as a bell, even just on my little radio. And then probably I was 10 or 11, and my parents or grandparents or somebody got me this really cool Sears radio that had like a TV band and
Wouldn't
AM,
you like
FM,
to still have that?
Oh, I would. And I hit that AM band, and it was like the sun wasn't even down yet, and I could get KMOX clear as a bell. And I was like, oh, this is the greatest thing ever. So if I wasn't playing ball or umpiring ball or whatever, I was in my room probably playing Stratomatic baseball, rolling dice, and listening to Jack Buck and Mike Shannon in the background. So again, it is what you get these experiences early in life, and it's something that just gravitates you. And whether it's baseball or math or epigenetics, it becomes a passion for you, or patent law.
Have you ever seen the movie Moneyball?
Oh, it's one of my favorite movies.
Have you ever read the book?
Oh yes, I read it. I read it every year. I read it during spring training every year.
I think Moneyball might be the best book movie combination out there.
It's fantastic.
And by the way, Michael Lewis is one of my favorite authors. He has been since like 1990.
He's great. I actually had a chance this weekend to meet one of my favorite authors. I met Ron Chernow in Hannibal.
Really?
He wrote Hamilton. He wrote Alexander Hamilton, and he just wrote a new 1,200-page biography on Mark Twain, which I picked up while I was in Hannibal.
I think I saw it sitting in here a while back.
No, those are different Twain books. I've read all the Twain books, but this is like the newest, latest one, and I have no idea. My oldest son, who lives in Chicago, also picked up a copy, and I have no idea how I'm going to find. We were both like, when are we going to find time to read this 1,200-page book? But
well, we're going off on a bit of a tangent.
We are, but this is fun. This is good stuff.
My career was determined by reading too.
Yes,
because I went into electrical engineering in the University of Nebraska, where I grew up in a small farming community in Nebraska on a farm. And in electrical engineering, I had a summer job. I worked at a hay mill. I operated the hay mill. I'd get all the machinery set up, running and everything. And then I had the night shift, and so I could read. I could get 2, 3, 4 hours of reading done at night doing this. And I was reading a book called, what was the name of the book? Oh, I can't, let's see, The Third Wave by Alvin Toffler. And in The Third Wave, he talked about technocrats, and he gave 2 examples of a technocrat. He said a technocrat could be a person with an engineering degree and an MBA, and they go on to be like a business leader in a high-tech industry or something. And then he said a different example of a technocrat could be a person with an engineering degree and a law degree, and they could go on to be, say, a patent attorney. And I just had this epiphany right then. I was like, okay, I'm going to finish my electrical engineering degree. I was like halfway through it by then. And then I'm going to get an MBA, and then I'm going to get a law degree. And it took me a long time, but I did that.
And you know what those guys who are in those fields are doing now? They're running baseball teams. They are.
Be, yeah.
I mean, a lot of the guys who took the Billy Bean and Bill James, Bill James before that, who took that concept, they're hiring these guys out of Yale and these other schools, and now they're the general managers of the baseball team, and they're applying all these analytics to baseball.
So the person who originated that field of analytics worked as a guard at a pork and bean factory
in Kansas.
And
Bill James.
Other businessmen swooped in and used it to make tens or hundreds of millions of dollars.
Well, he ended up going to work for the Red Sox, so he did okay too. And of course, he wrote a book called The Baseball Abstract, which I had every copy of from like 1982 to 1995.
Wow. What was the first one?
Well, the first one was like it printed off on just like
paper.
Right. The first bound one I got was the 82 version, because the Cardinals had won the 82 World Series, and nobody could figure out how the Cardinals, who only hit like 70 home runs, beat the Milwaukee Brewers, who hit 200 home runs. And he had this whole explanation of how speed and defense and pitching was able to offset power. And so like you said, it's just that kind of stuff that's fascinating, and that applies to this kind of stuff where you can look and say, okay, how can my genetic code be altered by by changing things in a cookbook?
Yeah, but I mean, in epigenetics, your genome or epigenome is even affected by the things you do now, like the shape you're in now, whether you're exercising, what you're eating, whether you get a disease, whether you go through some traumatic event, or whether you just walk every morning for an hour in the cool of the morning.
That's just fascinating. I mean, you always you want to try to improve yourself all the time, and you want to make sure, okay, how can I make my kids better and things like that. So that's the kind of thing you really need to think about as we pass this world on to the next generation.
Well, and one thing I'm wondering about is, because I fast periodically. Mm-hmm. I'll go without eating for periods. Sure. And ideally, I would fast for 3 days at a time, but sometimes I don't make it for 3 days. But I wonder what the effect of fasting is on epigenetics, and I've been kind of researching that, and I've not come up with a lot of answers on that.
I can't do that. I drink water, and then it's like, okay, I need the pizza or whatever. So, but I have been trying to eat better, and I've lost weight and all that good stuff. So, but no, I think I think this is just great stuff, and this kind of thing, just to make people think about things a little bit. I just think it's really cool stuff. So, what else you got?
Well, I could talk a little bit about how epigenetics works, which is kind of interesting. There are the 2 DNA strands that we talked about, and we have 30 to 40 trillion cells in our body, and a DNA strand, I forget how many it's one molecule. A DNA strand is one single molecule. I can't remember how many atoms it has, billions. But anyway, it's one of the more complex atoms there are. And if you were to take a DNA strand and hold it, it would be about 5 or 6 feet long if you stretched it out. So they're that long.
Wow. Okay.
But also they're not stretched out. They're wadded up and put into the nucleus of each cell in our body. And the DNA strands, the way they're histones, which are a protein, a tiny little protein molecule, and they form a histone. What do they call it? Octamer, and it's 4 different specific types of histones. And these histones are small, like let's say a glob of a molecule with a little tail sticking out. And they take four of these are lumped together, and then the DNA strand goes around them, and then it goes around them and around them and around them. And there are these histone octamers, like it's like a string of pearls or string of beads on a strand. And these tails sticking out, chemical markers can be affixed to these. And when chemical markers are affixed to these histone tails, it turns on or off. It expresses a gene. And that's one way of doing it.
Huh.
And
okay.
And also, this is an explanation from a layman who's no background in biology whatsoever. That's just done a little bit of research.
Why do I, when you say that, then I picture like a sperm with a tail on it swimming toward an egg or something like that? There's got to be some relation there, I would think. I don't know. So
could be. I don't know. Could be. Yeah. So, but I mean, the tails are so that, as the DNA strands wrapped around it, and it's so that something's sticking out that can be attached to.
Yeah. So, wow. I mean, it's just. Anyway, this is cool stuff. We learned so much, and again, you swap a couple texts back and forth about different subjects and things, and it's like this is just it's just really neat. And I hope people are enjoying something a little different here on Muddy River News to have these kinds of discussions that can deal with epigenetics, but then also can bleed into baseball analytics. It's good stuff.
Yeah, that's right. Yeah,
it's good stuff. So, Scott, thanks again. Always fun. And I just want to thank everybody again for watching this edition of High Tech in the Heartland.
Thanks, Bob.
Thank you, sir.